Yeah, we'll just go ahead and get started and see if a few more people join. And I'm Cleo Wolfie Hazard. I'm the new fire advisor serving Humboldt and Del Norte counties. And started back in January. Really excited to be part of this network. And today we'll be hearing from Kristen Shive, who's also a newer academic at ANR. She's a specialist at UC Berkeley, and her talk today, titled "The State of the Sierra Nevada," will explore how much area wildfire may be treating the mixed conifer forests of the Sierra Nevada via lower severity fire, and compare that to trends in treatment using a 2001 to 2022 study period. These trends can be used to support treatment prioritization, and they also highlight the difficulty and trade-offs between maintaining resilience on treated acres versus conducting first entry treatments in long unburned forests. So yeah, we'll hand it over to Kristen, and then we'll have some time for questions at the end. And if you have any questions, in the middle, feel free to put them in the chat, just if you're worried you're gonna forget them. And then, yeah, we have a nice size of group today, so we can have a conversation after we hear from Kristen. So thanks so much for being here.
Great. Thanks, Cleo and Katie, for organizing this. I will go ahead and share my screen. Okay, so as Cleo mentioned, I want to talk a little bit about an analysis that I've been working on with folks from the Nature Conservancy, USGS, as well as the Forest Service, looking at what we're calling the state of the Sierra, sort of the state of the Sierra Nevada forests, looking particularly for sort of challenges and opportunities around both wildfire and treatment. And so I always like to start with these graphs because I think it sort of reminds us all exactly where we are. That we've long had a lot of fluctuations in area burned in California. All my graphs are in hectares because I just presented a scientific conference. Hope that works for you all. But I think what we can see and that we know has been happening just in our lived experience is we're getting these dramatic increases in area burned. But 2020, which was this almost 4 million acres, huge year for us, and it felt like just the world was on fire. But of course, that's actually pretty similar to what we think the pre-fire exclusion average is. As you all know on this call, the issue is that it's just changing how it's burning. So specifically, I'm going to focus a lot today on those changes and how they've affected the yellow pine and mixed conifer forests of the Sierra Nevada. These were historically frequent fire forests, burning on the order of 8 to 15 years, depending where you were. And of course, as all of you know, I'll just rush through this basic information, but we've had these dramatic changes in fuels, and we're also getting a warming climate, which is increasing area burned, as well as the area burned at high severity due to increasing fuel aridity. And what that means is that we're getting more and more increases in high severity fire at really large scales. And that, of course, can have really negative effects on communities and also really negative effects at the watershed scale. So this picture is from the 2015 King Fire, and it burned thousands and thousands of contiguous acres, and that has huge impacts on watershed in terms of things like erosion, but it also has a big impact on forests and carbon, right? So the forest is basically lost at this whole scale, and because you need a live tree to seed in for the next generation, and those seeds don't travel far, that means a huge amount of this area is sort of out of the dispersal distance of live trees and likely not to be forested anytime soon. So we all know this is bad, and a lot of us work on this here. And so one of the things we're doing in these forests is to try to really increase that pace and scale, as policymakers always like to refer to, of thinning and broadcast burning. These are treatments that reduce tree densities and surface fuels, of course, and we've seen in wildfire, this is from the 2021 Antelope Fire, that it can make a real difference in how wildfires burn when they enter an untreated stand versus a treated stand. You can see green trees over there on the right and no green trees on the left. So the state and federal response, as I said, has been to try to increase that pace and scale of treatments. The Forest Service has put a lot of money into it. They've got a new wildfire crisis strategy. The Department of Interior is really doing much of the same. And we also have at the state the Wildfire and Forest Resilience Action Plan. So there's a lot of effort, going into trying to get more treatments done on the landscape to try to curb the negative effects of wildfires. Specifically, the state of California has partnered with the Forest Service with this, roadmap to 1 million acres, or the goal of treating 1 million acres a year by 2025, which, let's remember, is next year. And so, part of what I'm curious about is, how is that going? And what does that mean for wildfires on the landscape? And yeah. But the thing is, so we're talking a lot about treatments specifically, the mostly mechanical thinning and burning. But what I don't think we're talking about a lot is what you might term good wildfire. And by that, I actually don't mean managed wildfire. So a lot of you are probably aware that managed wildfire are fires that are allowed to burn, heavily managed, but allowed to burn and do good where they're burning under the right conditions. And that is usually in pretty remote backcountry areas. And I think those are awesome. And I used to work in Yosemite and I loved working on those fires. And it felt like such a cool thing to be able to do. But I'm talking about even in these lower elevation suppression fires, that there is actually good wildfire that we're not really talking about. So this map comes from the 2020 SQF complex, or Castle Fire. And if you look at this map, it's a severity map. All the red is at high severity of 90 to 100% forest lost. I mean, just gone. And it's awful. And we lost a lot of giant sequoias in that. It was a really, really a lot of negative effects. But if you look at this map, there's also a lot of those greens, oranges, and the two greens and the orange. Those are all areas where it burned at lower severity, and there are still trees left after the fire. And so it's not that I would call the fire good news, but I think we have to acknowledge that some of the effects may have been good, because those lower severity fires can sort of mimic the prescribed burns we do. A lot of variation on the ground, but the point is, they're areas that often have some fuels reduced and still have live trees post-fire. So they are things that we should be thinking about in terms of our management going forward. So the questions that we sought to answer with our spatial analysis, and that's all it is really a spatial analysis. There's no modeling or statistics. You'll see it's like simple bar graphs. And the first is, what are the trends in treatment and wildfire in these forest types? And the second is, how have they interacted to influence sort of the resistance to high severity fire across the range? And then lastly, how can this information sort of inform our priorities? What can we do with this information? So as I mentioned, we're focusing on the yellow pine mixed conifer, which we got defined by CalVeg, shown here in brown. It covers about 2.3 million hectares, or that's around 5 million acres. We focused on a period from 2001 to 2022, and that was based on some work by Malcolm North and others that suggests that 2 times the fire return interval is sort of the longest an area can go without being in a hazardous condition again. In other words, sort of if you had a treatment by the end of 22 years, it would basically, the fuels would have recovered and it's probably at risk again. In reality, that window is actually probably shorter, and there's a lot more work showing closer to 10 years, but we were trying to take sort of the most optimistic view. And we chose 2001 to 2022 in part because the severity data aren't even fully ready for 2023. So we got treatment data from everybody, from all the federal agencies, the state, to get at private lands. We got everything we could get our hands on. There are some holes, which we'll cover more at length in our paper, but we did our best to get all the treatment data we could. And we reclassified all the different treatment types into 3 very broad categories. The first is commercial harvest. So that had more to do with taking out larger trees, whether or not that was actually for economic gain or for restoration, because there's increasing recognition that there is a role for taking out some larger trees, even in a restoration context. Then we also classified what we called mechanical fuels management. So that's more treatments that are mechanical, but really focused on fuels reduction. So more focused on, say, ladder fuels. And then the last bin is just fire-related treatments, and that could include broadcast burning or pile burning. We then got fire severity data from across the range, and we included all fires over 81 hectares, or about 200 acres. And we used RNWR and CBI, these very common metrics of calculating fire severity. And we classified those maps into these three classes, where low is 1 to 25% vegetation change, moderate is that big bin of 26 to 75%, and high is 75 to 100%. Usually you'll see these kinds of maps presented with an additional class, which is undetected change, which means an area inside the fire perimeter where the satellite couldn't detect any change because there was no change in the canopy. Some of those areas may have had a nice underburn, but we don't know that for sure. Many of the areas don't, and so we just left that class out for our analysis and assumed that they were truly unburned. So these low, moderate, these are the severity classes that we're considering beneficial fire. And to be clear, there's a million caveats here. If you're on the very low end of low, it's possible that you really didn't reduce tree densities. There's maybe even still more surface fuels than you want on the ground. The very high end of moderate, you may have killed way more trees than you wanted. I mean, these are complicated, but in this range, we suspect, as I mentioned before, that you can have surface fuels reduced generally and some reduction in tree density. Live tree density, I should say. So making these assumptions, we then layered that data together to build a map that we call the resistance to high severity fire for this forest across the range. And to do that, we said an area had high resistance if it had a history of at least 2 restorative disturbances. So that's, any of the treatments or low moderate severity fire or fire-related active treatment. At least one of those disturbances, though, had to be fire, because over and over again, the literature is showing that it is that reduction in surface fuels that really makes these stands more resilient, and that mechanical only stands are just not as able to resist high severity fire. For moderate resistance, we call that one fire-related disturbance. Low resistance was 1 or more mechanical treatments. Even if it had multiple treatments, we still classified it as low because it lacked that reduction in surface fuels. Then obviously no resistance, that's no treatments for this time period. And then we additionally classified loss of mature forest cover, and that was just 1 high severity fire. We want to acknowledge that in some of these areas may reforest with time, and obviously some are being planted, but what we're thinking of is within this 22-year time span, it is no longer a forest. So at least at present, this represents a loss of the mature forest cover. And then lastly, we also classified areas with short interval, high severity reburns, which is something that has been really identified in the literature as potentially sort of that tipping point. There's a real concern for type conversion after high severity fire, where instead of forests, it's going to be shrubs and grasses in its place. Those areas then also have a lot of dead trees coming down. And with all those contiguous fuels, often reburn at high severity. And when they do, it's thought that that's potentially that tipping point to a more persistent type conversion away from forest. Okay, so going back to our questions, first we'll take a look at the trends in treatment and severity. So this is everything totaled together for all agencies and landowners. And you can see we've got those 3 treatment classes. I want to point out a couple things. One, the dashed lines represent sort of the average treatment, and it's about 12,000 hectares per year for commercial thinning, and around 4,000 per year for the other 2 classes. But you can also see there's considerable variation through time. The 2 things that I want to point out, though, is one, the peak was in 2008. A lot of that was driven by commercial harvest, and we'll see that next broken down by landowner. But still, since that declined dramatically after 2008, probably related to the financial crisis. Although things have been fluctuating, we don't have sort of this giant increase in pace and scale that I think we've been working towards. This is that same data broken out by the 3 major landowners in the region. And so that's the Forest Service, the Park Service, and then private lands. In the upper left-hand corner, so notice that you've got year on your x-axis there, and then the number of hectares treated on the y-axis. Note that each axis is different because they treat really dramatically different areas of land. But of course, part of that is related to how much land they manage. And so that number in the upper left-hand corner is basically how much land that they're managing per year. And I'd say on a sort of a relative basis, they're all doing, say, both the Forest Service and the Park Service are treating about 1% of their land area per year with fire-related treatments. But of course, there's a little bit of nuance under there, right? So the Park Service tends to do broadcast burns, whereas the Forest Service is leaning a lot more heavily on pile burns. A couple other interesting trends that I was seeing is one that there's sort of a decline around 2014 in the amount of prescribed fire acres that are being conducted or fire-related treatments. And this is around the time that there were major cuts to the fuels program on the federal government. And I think that although particularly in the Park Service, it seems like it's starting to bounce back, I think that is, basically that probably had a real meaningful impact on the ability of these agencies to get work done because they just didn't have enough staffing. The other thing I think is interesting and I think comes up in a lot of ways or in a lot of places, is that 2020 and 2021 were such big fire years that part of the reason, say, for example, the Park Service wasn't getting a lot of prescribed burning done is because a lot of fire personnel were out fighting fires. And so these, like, sort of the realities of conflicting resource needs is going to really be one of the main limiters probably of us increasing that pace and scale. I also just wanted to note that, in these years, particularly in the Forest Service, the commercial thinning still isn't super high. And one thing or hasn't fully recovered. And one thing that I do wonder is, in these years is when salvage logs, where both the Forest Service and private lands are going in and harvesting after high severity fire, that, a lot of managers will tell you that those logs are filling up the mills. And because of that, they can't go in and do as much work in the green forest because there's just nowhere to take the logs. I also wanted to note that there is an increase, though, in private land in both mechanical fuels management and fire-related treatment. And I think a lot of that is probably reflective of increases in funding from the state for smaller private landowners to do the work, which is really cool. Something I should have mentioned before is that there is some artifact of, the further back in time you go, the records just weren't kept as well. So we know that to some extent will influence how much we can say about trends, but we do feel pretty confident that after about the mid-2000s that they're really good for Forest Service and private land, and the Park Service is pretty good for the whole duration. Okay, so then now we look at trends in wildfire. And before we go, let me go back here. Look at the highest axis we have, y-axis we have for hectares goes up to 20,000 that's on private lands. And now for fires, we're looking at in that 300,000 range. And you can see there's also been a ton of variation, a really big uptick in about the last 10 years in terms of area burned. But when we think about those two potentially beneficial types of fire that we're getting in many areas, you can see that we've been getting quite a bit of it, and particularly in those two big fire years. That's a lot of land area. And if we put these on the same graph, I think it sort of really hits home just how much more area wildfire is treating than we are. So again, here's those two big fire years. That's our area treated, and that's where we're getting that beneficial fire. And I want to stress, these aren't unrelated. Again, as I mentioned before, these big fires can actually prevent our ability to get work done. But even before that, I think you can look back, and there are some years where we were doing a lot more treatment than getting wildfire, but most years wildfire is more or equal to. Moreover, a lot of that has been in commercial thinning, which is not always restorative, depending on how surface fuels are or are not dealt with. Okay. So that brings us to our second question. How do these things sort of overlay to impact the resistance to high severity fire across the range? So this is the map, the sort of the output we got when we did all that overlaying and classifying into those categories I mentioned below. So all those teal colors are, dark is high resistance, ranging up to the light teal is low resistance. All of the orange area are areas that have no resistance. They've had no treatment in the last 22 years. And then, of course, again, that forest loss in red, and in black is the areas with high severity reburns. And you can see that graph there is actually showing you the amount of hectares in each category. So on a percentage basis, this means that of this, yellow pine mixed conifer forest, 48% still has no resistance to high severity fire, which isn't really shocking to anyone here, I'm sure. 32% though has some level of resistance, and really 23% is moderate or high. So that's, those are areas that have had some surface fuel reduction. And that's more encouraging than I thought it would be. We do have about 19% loss of mature forest. Of that, or that 9% of that is likely out of the seed dispersal distance zone. So there are a lot of limitations to post-fire forest regeneration, and they can include climate, competition with shrubs, and probably many other factors I can't even mention here. But one of the big ones is, as I mentioned earlier, that distance to seed source. If most of that interior area just doesn't have a live tree near it, to share its seed, then you're probably not going to get forest regeneration. And so we did an analysis where we looked basically over 61 meters, which is like 200 feet, which is kind of considered the general dispersal distance for most of these species that are dominant here. And 9% of that area was going to be outside of that dispersal distance range. Some of it, of course, will be planted, but that's still a striking amount. And then just 1% of the range is in those short interval high severity reburns. So one thing that we, oh, sorry, I just realized the box is on there, but you can see the ABC on the map. So there should be boxes on there that just highlight the areas that we are sort of hone in on to sort of discuss a little bit about what's happening in the different regions of the Sierra. And the first is up in the Northern Sierra. You can get a sort of more of a close-up view. And this is almost all the Plumas National Forest. And they've gotten really hit hard over the last couple of decades. And I think what's really striking here is it has the largest proportion of high severity reburns and also really substantial areas of forest loss in terms of not just the percentage of the area, but in terms of the extent of the area. If we hone in on the Central Sierra, here's sort of like a bit of a silver lining in my mind. So you're looking here, it's just centered around Yosemite National Park, also the Stanislaus. And so those of you who remember the rim fire can pretty easily pick out that footprint. But what you'll see is that particularly around Yosemite, where they've been using fire for resource benefit for a long time, both in terms of managed wildfire and being pretty aggressive with prescribed burning, that the result is a lot of area that has some level of resistance, and a lot of it moderate to high. But that also goes for large areas that the rim fire impacted on the Stanislaus. And then finally, this is the Southern Sierra. They have really probably the largest proportion, like on a percentage basis, of forest loss. It's a lot of red there. They have a lot less yellow pine mixed conifer, in part because at that, down at that latitude, the elevations get kind of squished, and the elevation bands at which these forests exist are narrower. And this has had really big implications on two critical species of conservation concern. So the giant sequoia, where I work a lot. So these are some of the largest, oldest trees on Earth. They are truly irreplaceable, and we've lost, there's estimates of 13 to 19% of those mature trees in just a couple fire years, much of which is shown on this map. And then we also have the Southern Sierra population of Pacific fisher. They have been listed as endangered, and they really need like dense older forests in order to survive. Of course, there are probably too many dense older forests in this region, which is why it burned so incredibly hot. But now they're sort of faced with a real lack of the habitat that they prefer, and also loss of corridors where they can travel between different forests. And so this is considered, and actually in the listing for the species, high severity fires was listed as one of the biggest threats. Okay, so then the last question is like, okay, what do we do with this information? How can this help us going forward? And I think there's a few ways. One is just trying to put in perspective how hard some of the decisions we're going to have to make are. So this graph gets at retreatment needs. And so I just want to note that by the end of our study period, which was 2023, we were left with about 1 million hectares with no resistance. And so those are all areas that theoretically, as we increase our pace and scale, we're going to, sort of branch out into. But one of the things we have to think about is that all the areas that have had treatment are going to need retreatment. There's going to need another treatment to sustain those low fuel levels. And so what I'm showing here on this graph is a projection where we took the last year of treatment, and we are displaying this by resistance class. But we took the last year of treatment for a given acre and just presumed that in 22 years it would need another treatment. So again, this is a really conservative approach because we know a lot of areas will need retreatment sooner to maintain a low fuel condition, and particularly low resistance. Those are areas that have had no treatment of surface fuels. Those are going to probably need a treatment really soon. But if we just straight assume that 22-year-old window, you can see that the needs are going to be really, really great by the time we get out into the 2040s. I also want to point out that that red dashed line is the average area that was commercially thinned within our treatment period in the yellow pine mixed conifer, and that the orange dashed line here represents the average fire treatment and mechanical fuels management. So our needs are already somewhat outpacing what we can do. And we did some back of the envelope calculations and found even if we tripled our treatment rates, which it's probably going to take a while before we get there, we're still falling short of the need. We can branch more out into the unburned, which is great. But at some point, we're going to still have to make hard decisions about maintaining or enhancing what we have that has some treatment and some measure of resistance to high severity fire versus going into totally unburned forests. I want to just pause here and just note the thing that I hear a lot is people say like, well, manage wildfire. That's how we'll do all of our maintenance treatments. And I love that idea. And I think it can work in some places, but for so many areas, it's not going to work. And I think a lot of the yellow pine mixed conifer is those areas. They're lower elevation forests. So more often during the year when we get a lightning strike that can be managed for resource benefit, it's just too hot and dry down there to manage them. And in fact, I worked at Yosemite for a long time where we did a lot of these kinds of fires, and mostly they were not in the yellow pine mixed conifer. Mostly they were slightly higher elevation. The other thing is that there's just a lot, in this band across the Sierra, there's a lot more intermixing of ownerships and private lands and communities. And so I think we have to be realistic that managed wildfire is not going to be able to solve our problems in this case. And it's hard. I just want to, having worked on a lot of these fires, I think people think like, oh, Yosemite just lets their fires burn. It takes a ton of personnel and a ton of work, and they still put out most of the fires that start even in the backcountry. So I just don't want us to overblow this solution. It's going to take, but we have to more think about the fact that there just might be limits to the amount of land that we can care for and keep in the forested state that we want. Okay, so after all that negative Nelly talk, what do we do about this? I think that we have two important takeaways. And one is that we need to get realistic and set more meaningful priorities. And the other is to leverage that lower severity fire more. And I'll talk about those both in turn. So when I say getting realistic, what I mean is we should plan big. There are these giant landscape resilience projects that we're putting tons of effort into, and we should, because these big plans give us a lot of flexibility to sort of change direction if, say, a wildfire comes and burns over a planned treatment area or what have you. But I think it's tricky if we're not making the actual implementation plans based on the reality of what we can do. And a really good example that we probably won't put in our paper because we don't want to throw anyone under the bus, but I know of at least one plan that called for 7,500 acres of prescribed fire. And those of you who've been on prescribed fires know when you burn at the top first and you work your way down the ridge, and it just makes it easier operationally. But it doesn't mean that you always have to do that. Well, in this area, these folks burned a couple hundred acres, starting at the top of the ridge in the red fir, which is probably less threatened. And after 5 or 6 years, that's still all they've done of the 7,500 acres. The thing is, that's not surprising when we look at our treatment rates, and it's understandable. But if they'd been more realistic about what they could probably do, I wonder if they really would have started there. They may have started somewhere in the middle. I mean, you don't always have to start at the very top of a watershed, right? So I think how we consider I think our priorities will always be somewhat affected by what we think we can actually do. And so taking a hard look at that, I think, is a critical piece for moving forward. The other thing I think would be really useful is for folks to more overtly adopt the RAD framework, which is a resist, accept, direct, with particular emphasis on designating where we are just going to accept change. And I think we're already doing this by default, right? We are already doing this where fires happen and we lose forests over huge areas, and now we have to accept change, or maybe we're going in and trying to plant and in that sense resisting. But I think part of being more realistic is just going out and looking at maps and starting to say, you know what, this area, we can't really get there, and that's okay. And fire and drought are going to shape how that landscape looks moving forward. And I know that's really hard for managers and the public to do, and you don't want to feel like we're giving up. But I think this, by accepting that in some areas, it gives us more focus and resources to resist change or direct change in other areas. Then lastly, what I think is super important is to consider the potential to leverage wildfire. And I think that needs to happen in two key ways. The first is to just capitalize on these free quote unquote treatments in the low to moderate areas. Particularly when they're first entries, they're not going to be a complete treatment. Even when we're doing the work, we know in a very long unburned forest that you need multiple entries of treatment to get the stand into a resilient condition. But in many areas, at least part of the work has been done for us. So like I said, especially in high end of moderate, you may have killed a lot of overstory trees, and you may need to go out and do some mechanical work in there to pull those out so they don't accumulate a ton of heavies on the forest floor. In the low severity, it might be maybe it didn't take out enough trees. And so it'll really depend on the local conditions on the ground, but in a lot of areas, just that reduction in surface fuels is something I think worth capitalizing on. And that brings another trade-off, sort of where I was saying before, we had that idea that we have to think about maintaining treatments versus going into the unburned forest. Well, the other one is, do we want to finish a site that maybe had part of the work done by a wildfire, or do we want to take those same resources and go to the unburned and do a first entry, knowing we still need another treatment? And it's going to depend on a million factors in any given landscape, but I think these are trade-offs that should be more front of mind. And then the second thing that we should do more of, or we could do more of, is what we call using the black. And so, right after a wildfire, you get really big reductions in surface fuels, not everywhere, but in most areas. And those areas are where fire isn't going to spread for a while. And so a really good example, and I think you can use that as an anchor, and that gives you opportunities to potentially reduce the complexity of a prescribed fire. So specifically, this picture is from Redwood Mountain Grove giant sequoias. That's where what the black squiggly line is that outlines. And then we've got another fire severity map. And what you're looking at here is that unburned or undetected change area. And I've walked through this area like a million times because I've got work down at the bottom in the high severity area. And it is completely unburned. It's an unburned island. But down here, where it's high severity, there are no surface fuels. Now we're 4 years post-fire, 3 years, and there's the tiniest bit, but fire's not going to be carrying through there. And similarly here, where it was low severity, that area actually had several prescribed burns before. It's in great shape. And what my point is that this unburned island is surrounded by good black. And if the park had been able to sort of jump on this right away, because of course there's multiple years of compliance, et cetera, but if you could jump on that right away, that could increase, it could reduce complexity and increase the feasibility of getting that burn done when you can burn into the black. Okay, so that was a lot. And sorry, that went longer than I thought. So thanks so much to my co-authors and to you all for your attention. And that's it.
Thank you so much. So you said the paper is out?
No, we are trying to get it submitted in the next few weeks. We hope to probably realistically mid-August.
Okay. Well, I'm super excited about it and have a ton of questions, but I do want to open it up to the room and see if anyone has any questions or comments or thoughts right off the bat. And feel free to either unmute or put something in the chat. Okay, well, I'm going to start with my questions while you guys are thinking. Um, oh, go ahead, Jeff. Well, I work a lot up in Six Rivers, and we had last year 50,000 acres of this, what they were calling strategic firing. And so I guess my main question is, to me that seems like leveraging wildfire. They were burning into the black, and they were doing it right around a community at low elevation. And so I'm just kind of curious, um, yeah, to hear, and I think they're now Six Rivers is taking credit for 50,000 acres of prescribed fire that they accomplished right during that incident, using drones and ping pongs and all of those fun toys. And so I wonder, yeah, what with this work, kind of how you're hoping to shift the narrative around, what is a wildfire? Is it an opportunity to, you know, suppress, or is it an opportunity to burn? And how can we, obviously where you are also in relation. So I also had this question about, if you mapped kind of the WUI onto the resistance map, and that obviously, as you were noting, complicates things in terms of both land ownership and structure protection. But I would love to hear your thoughts on that.
Yeah.
Larger policy shift.
Yeah, I mean, I think some of what you're talking about is the choices that are made during an incident, and that is something that, thank God, 2009 they really changed policy and said, okay, now you can manage for both on a single incident. You can be putting it out near a community and allowing fire to do its good work everywhere else. And I think that is great, and I fully support. But I would kind of lump that in with managed wildfire. I think what I have been trying to highlight is once the fire that is like Castle Fire, nobody wanted that. There was no part where they were like managing something, right? They were like, put this thing out. And when they finally did, is there areas that good work was still done because it burned at night? There was a wind shift, that sort of thing. And so I think like both, both. I think there's room for both. I mean, one thing I'd say, like Cleo, I'm glad to hear that happened up by you, because even though that tool and that option has been available to the Fed since 2009, it's not capitalized on very much. And I think some of that's tough because CAL FIRE, frankly, and I know if anyone CAL FIRE people here, no shade, but I know after the Tamarack fire escaped where they had hoped it would go, CAL FIRE was showing up on every incident saying, you will put this fire out, so we're still a long way to go, and that's part of the paradigm shift. But I think both of them fit in the idea of learning to adapt to our new normal instead of trying to still think we can get ahead of it all.
Thank you. Anyone else? Yeah, Jeff.
If we've got time, really appreciated your talk. I'm kind of getting into the fire world from a social science perspective these last few months, so it's cool to kind of hear about this. I could look this up, I'm sure, but since you mentioned it, if you could maybe say something about the RAD framework and like what that sort of means for those of us less versed.
Yeah, so it's, there are many, I think, frameworks probably like this. I'm most familiar with it partly because it's the one the Park Service has embraced, and that is part of my background. But I think it was developed with folks at USGS. And it's really, there are a couple papers out there about it. And it's the idea of, taking a planning approach where you have to kind of zone off parts of your landscape and say, okay, realistically, long term, we know with active management, we can only do so much. And we're going to say, we're going to concentrate those things in this area. And we've been doing that for a while. But as I said, one, we were kind of overambitious, which I think might shoot us in the foot. But the other piece in my mind is that it's different to sort of just ignore something and then it burns up anyway versus just acknowledging. I think that there's a real strength in saying, we can't do the work here. We know we can't, and we're going to accept change here. And so it's sort of like a planning framework or planning exercise. And it's really about as simple as, resist change where you want to try to maintain forests, at least similar to what you have on the landscape, where you want to accept change. And then direct change is sort of, that's where, say you get a fire and you're going to plant different species because you see that it's getting hotter and drier, that kind of thing. I think that's where we have the most uncertainty. Where do you direct things to? But I think just starting with where are those accept areas on the landscape, I think is going to be really important.
Okay, well, thanks so much, everyone, for sharing your lunch with us. And yeah, really happy to keep talking over email, or if anyone's working on these areas, reach out to Kristen or to anyone in the fire network. And we won't be having a fire break in August. Hopefully some of you will be on vacation too, but we'll be back in September, and we'll be sending out emails about that. So thanks again, Kristen. Super important work and really interesting to me personally. And thanks everyone for coming.
Thank you. Thanks, guys.